Hello, this is Mr. Collier, and today we're doing some more problems with geometric sequences. So in the first example, it gives us U2 and U5. We have to find U1 and R, the common ratio. So I'm going to do this problem in two different ways. Firstly, I could write it out as a list of numbers here. So U2 is -12. We don't know U3. We don't know U4. U5 is 768. So how do we get from -12 to 768? Well, you multiply by r 3 times to get to 768. So basically we have -12 times r cubed equals 768. And we can divide both sides by -12, and we get, so that's 768 divided by -12 is -64. So that is -64, and that equals r cubed. Okay, so to get r, we have to do the cube root. R equals cube root of -64. And let me just show you where that is on the calculator. You can go to math, down to cube root, and I'm going to type in -64, and it is -4. So your R value equals -4. And the question also asks for U1. Well, you can actually just take your R value now and find U1. So this is U2 is -12. To get to U1, you need to divide by the R value, which is -4. So we're going to divide by -4, and we get a +3. So U1 equals -3. You could also find U1 by using the formula U sub n equals U sub 1 times r to the power of n minus 1. So now that second term in the sequence is -12. We don't know the first term. The common ratio is -4. Second term is, well, n will be 2, so that would be power of 1. So then we just get U1 equals -12 divided by -4. So U sub 1 equals 3. Okay, now your other method of solving this problem is, well, we know U sub 2 is -12, and U sub 5 is 768. So we can use the formula for both of these. U sub 2 would be -12, and that equals U sub 1 times r to the power of 2 minus 1. And this would be 768 equals U sub 1 to the power of r, or times r to the power of 5 minus 1. So again, -12 equals U sub 1 times r, and 768 equals U sub 1 times r cubed. And what we can do now is, so we can call this equation 1 and this equation 2. We can divide them, and we take 2 divided by 1, equation 2 divided by equation 1, we get 768 out of -12 equals U sub 1 times r cubed out of U sub 1 times r, and we get -64, so that should be a 4 here, equals r cubed, and r equals cube root of -64, which is -4, just like we did in the other method. Okay, so you can find the r value using either method. Okay, next example. In the next example, we're given U2 and U6. We're going to find U sub 1 and R. So this is a similar example, but something different happens here. So now, how many times did we multiply by R to get from U2 to U6? We're going to multiply by R 4 times. So we can say that 162 times r to the power of 4 is going to be equal to 2. And then we're going to have r to the power of 4 equals, we can divide both sides by 162, so 2 out of 162. Okay, so then we can take, and we know that r is going to be the fourth root of 2 out of 162. Okay, so let's do that on the calculator. You can go to math and go down to x root. Now we need to do, oh, I need to clear that. We need to do fourth root, so we're going to press 4, then go to math, then go to x root. So now I have fourth root of 2 divided by 162. I put that all in brackets so that it roots everything. Press enter. Now you get 0.33 repeating, and this is pretty easy to change to a fraction, but if you want to change to a fraction, that's right here under math, so we can convert to fraction, and we get 1/3. So that means our value in this case is going to be 1/3. Okay? Now, but here you have to be careful. If we have an even power here, or an even root, then we can have a positive or a negative answer. So actually we can have a positive or negative 1/3. Okay, so we can have either case, and that means we have two possibilities. So the first possibility is r equals 1/3. Second possibility is r equals negative 1/3. And we're going to have possibly two different u sub 1 values. So let's take a look at the first example. Let's look at the general equation for a geometric sequence. U sub n equals u sub 1 times r to the power of n minus 1. And we know that u sub 2 is 162. Okay, so I'm going to put in u sub 2. Actually, u sub 2 is 162, so 162 equals u sub 1. The r value is 1/3 to the power of, now it's u sub 2, so that's going to be 2 minus 1 here. So 162 equals u sub 1 times 1/3. And we can multiply both sides of this equation by 3. We can do 3 times 162 times 162. We get 468. So here we have 468 equals u sub 1. Okay, so if r is 1/3, we have u sub 1 is 468. And let's try it with r equals negative 1/3. So again, we have the same formula. And this is the same. And this is the same. The only thing different is the r value. And this will be the same as well, which will be to the power of 1 eventually. So we're going to have u sub 1 equals 162 times negative 3. So in this case, u sub 1 equals negative 468. So let's just show what both these sequences look like. If u sub 1 is 468, and the r value is 1/3, then your next term is going to be 162, and then you have to get 1/3 of that again, so that's going to be 54, and get 1/3 of that is going to be 18, and 1/3 of that is going to be 6, and so forth. With the second sequence, our first term is negative 468. Our next term is positive 162. Our next term is negative 54, and then we have positive 18, then negative 6. So they're very similar sequences, except one alternates negative and positive signs and one doesn't. But both those sequences have u sub 2 equal to 162 and u sub 6 equal to 2. So if you continue this on to the next number in the pattern, we have 2, and the next one over here would be also 2. So both of them have 2 and 162 in those terms. Okay, in example 3, given u1 equals 7 and r equals root 3, find the first term of the sequence which exceeds 50,000. Okay, so we're going to do this using the graphing calculator. Let's check out the general formula is u sub n equals u sub 1 times r to the power of n minus 1. So in this case, u sub n equals 7 times root 3 to the power of n minus 1. And we're going to type that into our graphing calculator, and we can't type in u sub n. So what we're going to do is we're going to type in the function y equals 7 times root 3, and this is exactly how we're going to type it in the calculator, to the power of n minus 1. So if we type that in, we'll be able to get a table of values and find out what's the first term that is going to be greater than 50,000. So let's get our graphing calculator, and we're going to type in y equals, we're going to press this button, y equals, and I've got it typed in here already. We've got y equals 7 times root 3 to the power of x minus 1. When you put an x, we can't use n. And what we can do now is you can graph it if you want to, and you can see what the graph looks like. If you press the second function, graph, that will be the table button. You'll get a table of values, and you can scroll down. You can see what the 6th term is, 7th term, the 8th term, and so forth. But we're interested in the first term that's greater than 50,000, and that would be the 18th term. So we can say here that therefore the 18th term is the first which exceeds 50,000.